Glenn, of course, has a lot of interesting insights, and I'm always excited to see his talk because he will bring in pictures from the past and show you things like the mainframes and computers that probably many of you have never seen before. And he's very can connect to where the future is, so I really find it always quite exciting. So you heard a lot of the vision. Where is US Ignite trying to head us towards? What does the future look like? What kind of things we can do? And all sounds very exciting. So let me kind of now connect it back to sort of what this competition is about. What is this challenge about? And what can you actually do to sort of help us with that vision and also win some exciting awards? So what is the challenge? So let me describe to you, within that broad vision that Glenn painted for you, you have all these different exciting areas in education, in trying to, connect people in interesting ways, in helping public safety agencies, and doing interesting things. What do we want you to do in the Paradrop Gigabit Challenge for 2018? So what we want people to do is to build what we call a Gigabit app. We want to kind of broaden it from, originally we were focused on smart homes, but we will describe to you what Paradrop is in detail. I mean, some of you here, probably most of you here know what Paradrop is, but I'll try to make sure we explain to you what this platform is and what you can do. So we want you to build a Gigabit app, and you can build any application that leverages this platform called Paradrop, and we'll give you a couple of examples. We'll give you some examples of kinds of apps we think you can build, but we will let you think about it and let you innovate, okay? So we don't want to restrict you in any ways, but we want to give you some examples that get you going, get you thinking of what is it that you can do with this platform. So the challenge, the goal here is to build and demonstrate this app by, say, early fall 2018. So you have really 6 or so months. We'll provide you with some milestones in the middle. We have actually quite a lot of funding, thanks primarily to US Ignite, who's sponsoring this, and we'll also sponsor it from the university. We'll have at least $20,000 in prizes, plus some money we have set aside for the teams that are building this app. So if you want to buy some stuff, cool gadgets, drones, whatever else, you have to explain why you need what you need. You can't ask me to buy a car for personal use, that's not allowed. But you can buy all the cool toys you need to build the application you're thinking of, and we will buy it for you. Okay, so minimally you can try out new stuff and it'll be very exciting. And then the best part, in my opinion, you'll get some money, that's great, it helps you in certain ways. But you, if the winners of this competition, we want you to be able to showcase your app at one of the US Ignite conferences. So it's probably unlikely you'll have something ready in a month to show in the Kansas City event that Glenn mentioned. But there will be another event in at least, at most a year, maybe earlier. And we'll find a way to have you showcase your app at that event. And you'll be showcasing that to more than 1,800 or 2,000 participants across all over the world. And it's a huge thing. Okay, so I think it's a very exciting opportunity to do that. Okay, so let me define what I mean, or what US Ignite and us, we all mean by a Gigabit app. So as the name suggests, a Gigabit app means an application that will truly leverage the availability of high bandwidth between either, say, the cloud or the end devices. Okay, so it's not like you're wasteful and just used a lot of bandwidth. That is not a Gigabit app, but you really needed to use a lot of bandwidth. Okay. We say gigabit in general. You can take that as a rule of thumb, 1 gigabit per second. But if you're using a large number of hundreds of megabits per second, that probably qualifies. We will not draw the line very fine. But you have to say that this is really not typical today. But if you could have an infrastructure which we will provide to you, and you could take advantage of it, and you could show some amazing capability because you had this high-speed network available to you. Okay. So that's one thing that qualifies as a Gigabit app. The second thing that qualifies is if your application could benefit by very low latency between the cloud and your end devices. Okay, very low latency, probably, as you got the hint from Glenn's talk, it's a millisecond, few milliseconds or less. Okay, so something that you can do if you had the ability to communicate with the cloud at that speed. Again, we'll provide that infrastructure for you, and if you can leverage it and show us something really amazing, that qualifies as a gigabit app. And then the way you will accomplish this, we will show you. Paradrop is a platform that can help you accomplish this. And if you can demonstrate something truly interesting in the different priority areas we talked about, transportation, education, public safety, and so on, that of course will qualify for what this Gigabit app is about. Okay. So let's take an example, and we'll explain to you what is Paradrop. So at a high level, Paradrop is this edge computer. Okay, what is an edge computer? You have the cloud, and we'll show you a little bit of this in more detail. It's a local computing platform that we have developed here in Madison, Wisconsin, on which you can write some software and can implement some capabilities. Okay, so when you build an app, you are able to put some capabilities, say, on an end device, which may be a security camera, a mobile phone, or something like that. You can put something in the cloud if you need to, and you can put something in this edge computer. Okay, and that edge computing platform is local to whatever environment you are considering. So, for example, in a home environment, imagine that this edge computing platform is your Wi-Fi access point. Okay, so in fact, right over here, I have one instance of the Paradrop access point. It looks, somebody told me it looks like a tarantula. It's actually a very interesting device. It has two 802.11ac Wi-Fi chips. That means you can get twice the speed of 802.11ac, which is a gigabit speed wireless, plus an extra wireless interface for monitoring and wireless speakers, microphones, all kinds of fancy stuff. So we'll give you one of these if you're going to play with it. It's a full-fledged sort of computer, and you can host services there. So that may be a device that's sitting in the house. And an application you can build is a public safety application where, let's say, God forbid, there's a fire in the house and the smoke alarm went off, and the edge computer, using various capabilities that you have developed, right? That's what we expect you to develop. You may assume there is cameras, there are smoke alarms that talk over Wi-Fi. There are maybe TV screens that respond to the Paradrop platform. And if a fire is detected and the smoke alarm goes off, somebody picks it up. Maybe it's through the audio capability of the edge computer, like Paradrop. You enable some cameras. You can provide that feed to a remote first responder, and that person can then talk to the residents in the house saying, are you guys okay? You can see the feed, you can share the feed, and you can do something very fast, which you cannot do if you didn't have a computing platform in the house. So what is the Gigabit app here? So number one is that the response time for certain reactions can be very fast because the software is running on a compute platform in the home. It's not going to a cloud. And maybe if the fire is spreading very fast, it can immediately take snapshots from the video camera, process it, and share it with a first responder who's entering the home and direct them where they should or should not go. Okay, so what we wouldn't, this is just a made-up example, but somebody came and said, we will build an app which will be a very exciting public safety application in the home. It requires 3 cameras, a smoke alarm detector, and a couple of other capabilities, maybe microphones, and you set it up in the home, and in case of a fire, this is the kind of things it can do. Very fast response, helps the first responder as they walk into the home. Okay, so that's the kind of things we are expecting you will do. So another example is in education, right? So this was an example shared with us by some people. They said, well, imagine that a student is usually in the classroom, but one day the person fell sick. Okay, so of course the person's missing out on all the experience in the classroom because the engagement with the peers and all that is not going to happen. So what we want to do is to enable the student who is in the home because the person's sick to be able to have the total classroom experience. Okay, so what we could do is we could use virtual reality technology, right? So the person in the home puts on a VR and virtually is in the classroom. Okay, And therefore, the person can engage with the entire class as if the person's there. He or she can see what the classmates are doing, interact with the teacher, follow along in other ways, and do interesting things. So again, you have to build this end-to-end system. And the key here is that imagine there could be one or more people in different locations who may be absent from the physical classroom but are in the virtual locations in the classroom through their headsets. And how do you enable that kind of a service? You can again use Paradrop, which we will describe a little more in detail, which will assist in streaming the VR content between the classroom coming in to the headset that you're wearing. Because today VR systems tend to have a lot of delay unless you have some very high bandwidth wired connection to your headset. Okay, so there are all kinds of things like that that you can implement. So I'll describe this briefly. Our formal launch will happen a bit later. So this is sort of a sneak peek for all of you, but we will be doing some official launch on the start date. And I think we'll also be running a tutorial on Paradrop sometime, I think, in early April. That is our plan. So anybody who wants to really learn how the Paradrop platform works, we will run a tutorial. It's free, open to anybody, and you can play with it to understand what exactly you can do with this. And then towards late April, we will request everybody to submit a preliminary idea, write up 2-3 pages what you want to do, what is your idea, how you want to accomplish it. And then we want to see some initial progress. And we are thinking that by mid-May, and these dates may change a little bit, but we will want to provide some preliminary awards. We'll select teams that we will say, okay, you guys can go ahead. We'll give you some initial money so that you can go and do certain things. And by early fall, we want to see a reasonable demo of the system that you're developing. Okay? So the resources that you will have at your disposal for this competition is the entire Paradrop infrastructure that I'll describe in the next 5 minutes. And we'll also cover the cost for you to buy any gadgets that are relevant to your project. So you have to define what your project is, anything you need, Nest thermostat, bunch of sensors, things you put in a car, cameras, all this stuff we'll buy, drones, and you have to justify, but in the end we want to see that you can put this all together and create an exciting application across any of these different domains. Okay? I want people to think big, okay? Don't think of obvious things, but these are sort of examples of things you can have today. You have video cameras, you can have Wi-Fi enabled speakers, smoke sensors, smoke alarm sensors, virtual reality headsets, thermostat. But think of anything broader, drones or whatever else to deliver something that makes a big difference in people's lives, in society's lives. And we will be more than happy to enable all of that for you. Okay? So now let me tell you in 2 minutes or 5 minutes a little bit about Paradrop. I think most of you know this, but I still want to do this for the sake of completeness in this talk. To do that, Paradrop is an edge computing platform. And to do that, let's make sure we all agree what is cloud computing first. Cloud computing means you centralize computing resources in the way Glenn described it. You have a central location where you put computing. That's good because I don't have to worry about where my servers are. Somebody else is taking care of it. That's really nice. Edge computing means we are thinking of putting smaller computers closer to the edge of the internet. Now, people are doing this inside ISP networks because ISPs can manage these things. And what we proposed in Paradrop, I will jump ahead, is that we want the Wi-Fi router, for example, your home Wi-Fi router is an edge computer. Okay? So that is a computing platform. We don't think of it as a computing platform, but it is. Of course, it sends Wi-Fi packets back and forth, but it is a computer. And we can treat it like a server. Of course, it's not the most powerful server you can imagine, but it can be a server, and we can make it powerful. The one we have, the one we actually utilize for our projects, is more powerful than probably your home Wi-Fi because it's equipped with a more capable CPU, with more memory and better storage, and highly optimized wireless capabilities with high-speed networks. And the idea is that we instantiated this to allow virtualized hosting of components of software. Okay, just like you can create a virtual machine and put it in a VM in the cloud in Amazon or Azure, You can do sort of similar things in this Wi-Fi router. Okay, and the Wi-Fi router is interesting because it is always on, right? It's in the home, it's always on. I don't think anybody turns it off when you leave the home. It is low latency to all the gadgets in your home. So that's why you have the low latency experience. It's a millisecond or so, even less sometimes. And so, and it's on the path of all your traffic to the internet. Okay, so that's kind of an interesting point where you can put some computing. And if you do that, you can actually have interesting controls for things in the home. So I'll give you an example or two, right? So today, if you want to do intelligent control of your home's temperature profile, I can imagine that I can decide that when I'm in a room, I want the temperature to be high. Maybe my wife cares less for high temperatures. When she enters the room, it becomes a little lower. When none of us are there, it becomes even lower, right? I can create something like this. But how do I accomplish this? One way to do this is by saying, when I detect a person in the room, I will open or close the vents according to increase or decrease of airflow that I want. Okay? So what do you need to do? You need to put a bunch of sensors. You need to put actuators that will control your vents. And then you need to have some intelligence somewhere, which is based on the presence of a person, based on which vent is open or closed. I will change the configurations of these vents. So today, where can you write that software and put it? Well, if you're a third-party vendor, like probably all of us, we'll have to write this and put it in the cloud, right? All the data goes to the cloud from the sensors. Then we write a little logic saying, oh, a person is detected, we should open this vent, and then some instruction goes back and it opens the vent. But that is very slow. You're sending unnecessary traffic to the internet. You're also sending very private data about the home to the internet. That may not be very good. Instead, if I give you the capability of putting that software in the Wi-Fi router in the home, that is very effective. It's a few milliseconds away or less. And that's where the software can reside. Okay? So that is what Paradrop is really trying to do. You can have many other examples. You want to do intruder detection in your home. There are companies and products that do that. Things like Dropcam, right? It will send all your video to the cloud. And that's not great for everybody's privacy because I don't want all my home video to sit in somebody's cloud. But if I can enable my Wi-Fi router to be the storage of all this video coming from Dropcam, okay, and it does the processing and it decides, oh, there's an intruder detected, then I don't have to send my video to the cloud. I can do this processing locally. So again, somebody may come up with such an idea and say, I want to do this little computing in this Wi-Fi router because then I can implement this new service, which otherwise would require too much bandwidth that is not really necessary, or it requires a very low latency, which I don't otherwise have from the cloud. Okay? So the way Paradrop works is we let third-party developers like you, potentially, to create some app running in a container, and you insert it into the Wi-Fi router. So if you come to the tutorial, we'll explain how exactly you'll do this. It's actually very simple. And if you're familiar with something called Docker, we use Docker. So if you know how to use Docker, or if you learn it, it's very easy. Then you can just write your code. It sits in a Docker container, and you can push it into the Wi-Fi router in a very simple way. Okay? So, we view Paradrop as a very transformative technology. Just like the iPhone came and transformed the old mobile phone, we view Paradrop is the technology that can potentially transform the Wi-Fi router market because we make the Wi-Fi router to be more than just a thing that forwards Wi-Fi packets back and forth. Okay? So the way it works is that we call this thing chutes, okay, as in parachutes. So you parachute some code into the Wi-Fi router. Chutes are basically these Docker containers. Okay? Think of them as, if you're not familiar with it, think of them as very lightweight VMs, virtual machines. So on demand, you can put these virtual machines into this Wi-Fi router. And they run in their isolated environment. And you can, as a developer, you decide what goes in that software. You control how that manages and manipulates things and gadgets in the vicinity. And our Wi-Fi router, the Paradrop router we have developed, has multiple interfaces, Wi-Fi and Bluetooth and audio. You can use audio in interesting ways. You can use it to potentially localize where somebody is speaking from, like Alexa and many other gadgets. And you can interact with all these interfaces programmatically. Okay, you can develop a logic that takes advantage of all of these things. Okay, so because we use Docker, if you're familiar with Docker, it makes life very, very easy. And the process of instantiating these shoots and revoking these shoots is also very easily done within our platform. Okay, so how does it work? We have a cloud manager. So edge does not mean that cloud is irrelevant. It is still relevant. We have a manager to manage Paradrop routers. And let's say you have an idea. You have a new way of managing security cameras in the home. You developed it. You came up with a solution. So when those, the way you should set it up is when these cameras get installed in a particular home, you will have your own cloud manager, which will drop the Paradrop shoots into appropriate Paradrop routers. Okay, you will use our API. We'll provide you with APIs using which you'll drop these shoots. And what is in the shoot? That's up to you. You decide. Okay, the shoot will pull data from the camera, store it locally, save it, do some local processing, alert when an intruder is detected. You do that. We provide APIs to enable you to do that. Somebody else came up with an idea that I want to do temperature sensing, and when it's too hot, send some alerts or whatever, right? So maybe you've developed another solution for that with some hardware, which are temperature sensors. And again, that developer using their own cloud will use our APIs to instantiate the appropriate shoots in this environment. Okay? And in some cases, you may not have specialized separate hardware. You may simply write some software that sits in the Paradrop router, standalone, maybe talks to some mobile devices, or just a standalone thing, and doing whatever it needs to do. Okay? So we have provided you with this abstraction and API to deploy applications into these Paradrop routers wherever they are available. Okay? So now as a developer, you have an option of putting or developing three pieces. You can choose to develop something that sits in the edge, which is of course required if you want to use Paradrop. Otherwise, you don't use Paradrop. You can develop something that's in the cloud and something that's in the mobile device or the end user gadget that you're using. So in the traditional model, if you develop some application, you create an end device solution, which is say an app, mobile app, or some gadget, and something that is written to run in a VM in the cloud. With Paradrop, you're introducing a third piece, which runs in this edge. Okay, so that's what your capabilities are. And when we do the demos, which Lance will do in a few minutes, he will show you some of the things we have developed. These are just toy examples. You can do much better. You can use it to stream data to a VR headset to do it much more efficiently. And I want everybody who's participating to think broadly and innovatively. Things you cannot do very easily in absence of something like Paradrop. Okay, so we have done things like transcoding of video. If the video bitrate is too high coming in, I can change the video bitrate on the fly inside the Paradrop router. These are simple examples and not meant to be the most illustrative ones. But you can cache movies locally. You can do fine-grained environment control, the example I talked to you about, so I'll skip over it in the interest of time. We have developed some technology where we ran an application that controlled these vents. We developed these vent controllers. We developed temperature sensors. And based on the feedback from the sensors, we chose when to open and close different vents. Okay? That intelligence, that software, ran in Paradrop inside a shoe in a particular VM. Okay? So I will jump ahead and basically summarize by saying that if you want to participate in this competition, we will send you an announcement just to let you know when the official launch is and how to sort of apply, which I have hinted at. You write a little summary of what you want to do. But we want you to think big. Think of what you can do, which will be very cool. You saw the examples that Glenn pointed out. He's talking about, fancy microscopes, sending 4K images to a remote location. But, there are exciting opportunities in education using, imagine a classroom full of people all wearing VR headsets and watching a VR stream coming from the field somewhere and being able to stream it to everybody. Those are challenging tasks. And we'll give you time and resources and funding and everything to get through all of these things. Okay, so with that, I will hand off to Lance Hartung, who's academic staff working with us, and he and many other colleagues here actually have developed a lot of the Paradrop platform, and they will do a few demos just to give you a little bit of a teaser of some of the capabilities. But the possibilities are much more exciting and endless. So with that, let's.